This video is about polynomials in Matlab. The topics covered will include what is a polynomial, how do we use the special polynomial functions inside of Matlab, such as calculating the values of a polynomial, calculating the roots of a polynomial, determining the derivative of a polynomial, and finally, how do we determine the polynomial that best fits given data points. So first, what is a polynomial? This should be a reminder for most people. Polynomial is a function that uses only addition, subtraction, multiplication, and exponentiation of a variable. So polynomials of one variable are very common, simple functions, such as the one shown here. F of x is 2x cubed plus 4x squared minus 3x plus 1. The degree or order of the polynomial refers to the largest exponent. So this polynomial is of degree 3 because the largest exponent is x cubed. The coefficients are the constant factors multiplying the variable, including the final constant. So this polynomial has 4 coefficients. In order they are 2, positive 4, negative 3, and positive 1. In Matlab, there are a number of built-in functions for single variable polynomials. These functions use an array of the coefficients. For example, this function, f of x equals 11x plus 4, the polynomial functions built into Matlab will treat the array 11, 4, this two-element array, as if it were the polynomial 11x plus 4. Or this example, which will carry through the Matlab examples I'll show you next, g of x is equal to negative 5x to the fourth plus 9.5x squared plus 3 would be treated as this array by the polynomial functions built into Matlab. Negative 5 corresponding to negative 5x to the fourth, 0 corresponding to 0x cubed, 9.5 corresponding to the 9.5x squared, 0 again corresponding to 0 times x to the first power, and 3. It's important to note there's nothing special about these arrays. It's just that the built-in polynomial functions, those functions built into Matlab, will treat these arrays as if they were the coefficients of the shown polynomials. The number of coefficients indicates the degree, so make sure to include all 0 coefficients wherever they exist. Let's look at some examples now in Matlab. So first, let's get the value of the polynomial that I just showed. Negative 5x to the fourth plus 9.5x squared plus 3. Specifically, what's the value of that polynomial at x equals 1, or at other values of x, or over the range x from negative 2 to positive 2? First, let's enter that polynomial as an array. We'll call it f, and the coefficients were negative 5, 0, 9.5, 0, and positive 3. I'll put a semicolon at the end. Okay, the function polyval gives us the value of a polynomial. So first we give the array which holds the coefficients, and then which value of x we want to evaluate the polynomial. So the value of that polynomial at x equals 1 is 7.5. If we want to get multiple values, then we can give an array instead of the single number at the end. So this tells us the value of the polynomial at x equals 0 is 3, and at x equals 2 is negative 39. If we want to know a range of values, then we can quickly make a plot by plotting, let's create some x values, negative 2, counting up by 0.01 to positive 2. Let's plot x versus polyval fx. And here we see the polynomial evaluated from negative 2 to positive 2 gives us that shape. Now let's look at the roots of a polynomial, and we'll keep using the same polynomial. The roots are the values of x for which the polynomial equals 0. So the function roots tells us the roots of the polynomial, and we can see that 2 of the roots are imaginary, 2 of them are real, plus minus 1.475. And if you plug these values into the polynomial, you'll see that you do in fact get 0. If we want to know which polynomial has particular roots, then there is a function poly. So give to this function an array which represents the roots. So which polynomial has roots at negative 3, negative 1, positive 1, and positive 3? It's the array x to the fourth power minus 10x squared plus 9. Now for derivatives, there is a function built into Matlab which will determine the derivative of a polynomial. So if we want to know the derivative of that polynomial f, then we use the function polydir, and this tells us the derivative of that polynomial f is negative 20x cubed plus 19x. If you want the second derivative, you can do this again. So the second derivative is negative 60x squared plus 19. And we can even plot maybe the function and the derivative of the function on the same graph. Oops. If you want to know where the minima and maximum are then of a function, then you can ask for the roots of the derivative of a function. Right, so where the derivative is equal to 0, that's where the minima and maxima of a function can be found. Now let's talk about curve fitting. So if you want to fit data to a polynomial and figure out which polynomial of a given order best fits a certain number of data points, then there are, again, built-in functions into Matlab. So we'll be using these example data points shown here as xy pairs and seeing which line and which third-order polynomial best fits these data points. The first step is to create an array of your x values. So those were 0.9. As shown, and create an array of y values. Okay, first let's just see what that looks like. Let's plot x vals versus y vals using maybe black stars. Okay, so here's the data, and now let's see what is the line that best fits and the third order polynomial that best fits that data. The function polyfit returns a polynomial given x values, y values, and then the order of the polynomial you're hoping to use. So this is the polynomial, this is our coefficient array of the first order polynomial, or the line that best fits this data. So this would represent 0.5688x plus 0.9982. And if we want to plot this, then let's create some x points to plot, maybe from 0.9 up to 9.5, because that was our range of x values. And let's get some y points to plot, which would be evaluating that polynomial that we just created over that same range of x values. And now let's plot the x values versus the y values as black stars, and then our best fit line. And there we have in blue our best fit line, and in black our data points. If we want to do the same but with a third order polynomial, then we can come back up here, maybe change the name and use a third order polynomial. So this represents 0.022x cubed minus 0.4 or so x squared plus 2.6x minus 1.4. And let's create some new y points for our third order polynomial. And now let's go back up and plot our data points in our best fit third order polynomial. Okay, so that shows you some of the functions built into Matlab that has to do with polynomials, both evaluating and getting the derivative of a polynomial that you input, or inputting data and getting the best fit polynomial.